Uh, I am starting with first of all, we'll see the networking devices. So we discuss about networking cables type of network. We'll see networking. Main important device, hub, switch, router, modem. Hub, switch, router, modem. So what is the hub? It is a LAN based device like we are using in LAN, used for a small networks. Switches also for a LAN purpose only, small and large networks, and switches having a capacity to understand MAC addresses. Router we use for both LAN, WAN, internetworking, and also router shows the best path to reach the destination. Routers work with IP address, switches work with the MAC addresses. Modem is make you to connect it to internet via ISP. So you can use via telephone cable, optical fiber cables, we can connect. Okay. So again, these are the basic devices we use. Important devices are hubs, switches, routers, and modem. In this one, repeater is also there. What is the repeater? If you want to communicate, like normally our cables, these cables support up to 100 meters, but you want to communicate longer than 100 meters, so we need a repeater. Sometimes we use a hub as a repeater, or we can use a device called a repeater. Very simply say Wi-Fi extender is there. It is nothing but a one kind of Wi-Fi repeater kind of stuff. What is Wi-Fi extender? Yeah, someone put it. Okay, so data transmission depends upon the cable. Like if you want to transfer 10 Mbps, we need a cable according to it. All participation means data transmission speed, not only cable, also your device, source device, destination device, intermediate device, and the cable. All purpose. Like I am using Cat6 cable, 1 Gbps internet speed, 1 Gbps speed, but switch is 100 Mbps speed, and your destination 10 Mbps speed. This LAN is 10 Mbps speed. So what is the least one? This speed only can able to transfer, not this speed. Can transfer on Gbps, but overall communication is based on the least speed. Okay. So
Yes,
you
sir.
are using you are using a fast Ethernet, 100 Mbps, but you connected a Cat6 cable that is 1 Gbps capacity transmission, but data transmission is 100 Mbps. You are having your internet is only 10 Mbps, for example. You are having a gigabit connectivity, but still you are getting 10 Mbps. So it's a not average. It is what is the most least one. That much only we can able to try. Okay, so very good question. So we'll see one by one device, guys. Very simple. Hub. What is a hub? Hub is a non-intelligent device. It does not understand what is the IP address or MAC address. It is used in a LAN and suitable for small networks. As per OSA layer, it is a physical address. Sometimes we can use this hub as a repeater and it repeats the signal, so then we can communicate a longer distance. The repeaters does not boost your signal, only it repeat the signal. So hubs act like a repeater. For a repeater, as I said, like it is Wi-Fi extender is best example in a Wi-Fi network. Next, how this hub is works, why it is suitable for a small networks, why not for a larger networks? We'll see. Guys, look at this is a hub network. In a hub network, okay, in a hub, how it is communicate? You have a computers, okay, you have a computers, and you have a hub. So why I have written? So I needed some space to it. OS layer, or that is we will explain separately. Okay, so just note down the point. OSI layer having 7 layers. It is a reference model. Okay, so we use a OSI layer to understand how network is connecting, communicating. Okay, so first we will discuss that. Guys, here it is. It's a PCA, PCB, PCC, D. This is hub. This centralized device is hub. Okay, device is hub. How it is connected like this. Or if you want to see the pictures like a PC hub connection. So only guys, we don't need to show you everything, okay? But you can try yourself. Like this is hub is connected, but it is showing a hub means it thought it is a USB hub, but no, that is not my point. It is showing wrongly. Yeah, like this is the hub and the PCs are connected. This is a hub. It is look like this one. Okay? So network hub. It is look like this one, and using the cables will connect it. Powdered USB hub. It is showing switch network, switch hub. So you may get an idea. So this is the hub device. Hub and switches both are look like a same, but it function little different. This is the hub, and it is devices are connected like this. I want to show you the how really it is connected. Like this is see it is a netgear switch or hub. It is the cable is connected like this. So we are connecting our computers directly to it. Next. So when we are connecting, what will happen? Data is transmitting. Like here it is a communication from A to B. A want to send a packet to B. A want to send a packet to B. How packet will travel? The packet sent to the first packet is travel to hub, hub to BPC, hub to CPC, up to FPC, up to EPC, up to DPC. Okay, so to whom it should be communicate, guys? A to B. Packet has to send to A only, but it is sending to C, D, E, F. So this is called a broadcast. This is called a broadcast. It is not only sending to B, it is also sending to every others. So when our other devices received, what they will do it drop the packet, drop the packet. Because in a packet, we have a source IP, destination IP is there. So they will check it is belongs to me or not. So you received a package, and the address is not your address, or maybe that is a different address, but you received it. Then what you do, it is not mine. That's the kind of stuff we do it, drop the package. Next. BPC check. Oh, this is my packet. So because when it is sending to address is B, from address is A. So B knows it is my packet. It accepts the packet, remaining device of the packet. Okay. Similarly, so I am telling another story, right? It is this story. So C want to communicate to EPC, for example. C send a packet, packet travels, send to F, send to E, send to D, send to A, send to B. So what will happen here? It's not belongs to A, it is not belongs to B, it is not belongs to D, it is not belongs to F. So is accept the packet, E accept the packet. But every time each pieces are communicating each other, but every time it is broadcasting, what will happen here? Lot of collisions will occur. Lot of collisions, packet collisions will occur, then packet data loss will occur. The packets will be die here. Okay, collisions will occur. Means same path only, same packets. Lot of packets are came, lot of confusion occur, and they will collide each other and a packet loss. Then packet loss create retransmission of data. Packet is lost. Again you have to send it again. Then again you have to send it. Again you have to send it. It will create more traffic. That's why it is suitable for a small networks. If it is a 5 computers are there, okay. 10 computers are there, not okay. 20 computers are not at all, okay. Because the 5 PCs create a lot of traffic, and if it is 10 computers, will create lot of traffic in the hub. Let's understand what is the use of this hub. Small networks, we can use it. Why? Again, why we should use? Because it's cheaper. You have a 2 3 computers. You don't buy a switch. Okay, better we use one hub, that is enough. The work will be done, right? Because hubs are also availability of hub with a smaller port numbers only, 4 port, 6 port, 8 port hubs only available. So we don't use 16 port hub or a 24 hub kind of stuff. For switches we use it. Yes, understand hub?
Yes, sir.
Yes, sir.
Next is switch. Switch and hub both are look like similar. For example, you take 8 port switch and 8 port hub. You may not find much difference directly. Okay, so that is first important. Next one is both are used for a LAN communication. Both are used for a LAN communication, and we can use it for a small and large networks also. Large number of devices we can connect it to your switch. Both small networks, large networks, we can use it. Large number of devices we can connect it. Number of collisions are less packet data loss. So that's why it is suitable for a large networks. Okay, and it is as per the OSA layer, it is layer 2. I will tell OSA layer, so don't worry. So as per the OSA layer, it is layer 2. Each port, sorry, layer 2. That's it. And the switch having one more important is it is an intelligent device, means there is a circuit inside to understand MAC addresses. It create a MAC address table by learning MAC addresses of a devices. Every device has an NIC to connect, and every NIC has a MAC address. So when this switch connected to this, automatically this switch learn the MAC address and maps to the port. Okay, so that is I will explain. Next, yeah, it is a layer 2 device So switch is a layer 2 device, layer 2 switch. But there is a layer 3 switch is also there. So layer 3 switch do the function as a switch as well as a router, and where we use in the different concept like a inter-VLAN routing, internet communication kind of stuff. That's the additional point, guys. So switch is a layer 2, but there is a layer 3 switch is also there. That is called a multi-layer switch used for a different purpose, like inter-VLAN routing kind of stuff. This is a diagram for understanding of switch, how differ from the hub. Same diagram only, so no difference in it. So this is a switch. Okay. Computers generally talking. Wireless devices and wireless switches, wireless access points works differently. Switches has a CSMA by CSMA by CD. What is CSMA by CD? Or CSMA by CA? Carrier sends multiple access. Collision detection. CD means collision detection. CA means collision avoidance. Wireless use this technique called a collision avoidance to detect the collisions. So not regular switches are CD. Wi-Fi connectivity is a CA. Don't worry, I'm not telling any some story, so I'm telling. Yes, again APC, DPC, 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 E. Okay. So here for our understanding, I'm taking this APC's MAC address as a A1, BPC MAC address as a B1, CPC MAC address as a C1, DPC MAC address as a D1, E1, EPC MAC address, F1 is a F, FPC MAC address. Just for our understanding, and they're having their own IP address. What is this device, guys? It is
Switch.
okay. So same connectivity, same LAN connectivity it is. Now, what will happen if I want to communicate between A to B? A send a packet as such, so A to B communication, A has to send to B. So then packet travels to the switch, switch to B, switch to C, switch to D, switch to E, to F. Those are connected, it broadcast. Why it is in the switch, I will tell. Initially, it works like a hub only, but when it is sending and receiving, it creates like this. Sorry. I forget to add a points here. It is port number 1, it is port number 3, 4, 5, 6, for example. It's a port number 1, port number 2, 3, 4, 5, 6. So it creates a table. So my switch port phone number. It is a switch port number. The connectivity switch port number. Okay? Switch port number, and then it is your PC. This is MAC address. The PC is MAC address. So when A is communicating to B, so A is connected to first port. The MAC address of A is A1. Just for understanding, A1. And next and next, C is trying to communicate to B, for example. One is better, this is better. C is C to E. Same, C go to here and reaches F, E, D, and B, like it's a broadcast. But what it will do, C is connected to 5, okay, and C's MAC address is C1. Like that, it creates, okay, it creates each one. For example, 3 is connected to B, B's MAC address. 2 is connected to D, D's MAC address. 4 is connected to E, MAC address. 5 already completed. 6 is connected to F. Okay, so it will create a MAC address table. Now one example I will take it. So like this. So for example, now I have a MAC address table. Now, so B want to send a packet to D, B to D communication. B to D communication. B send a packet to the switch send a packet to D. That's it. How it will send? So it see the destination MAC address is D1 and D1 is connected to port number 2 and it will forward the packet to port number 2. Okay, forward the packet to port number 2 and it is connected to here. So that is destination MAC address is D1. D1 is connected to port number 2 and forward the packet to the port number 2. No need of broadcasting. In a hub, it always broadcast. In a switch, initially there is a broadcast, but once it is done, learn the MAC addresses and map it to their port numbers. So it is easily done using this MAC address table. It is MAC table or a MAC address table. MAC table or a MAC address. Okay, this is it. Switch initially use broadcast. Once MAC MAC address table is created, it uses unicast type of communication. Again, what is a switch? Switch is an intelligent device. It maintain a MAC address table. It learns the MAC addresses of devices and map to the switch port. Switch uses in a LAN communication. It is a layer 2 device. It understands MAC addresses. Okay. It is used for a small and large networks. Of course, some people will get a doubt, guys. It is hubs and switches are used in a star topology. Star topology. Let's understand hub and switch.
Yes, sir.
This is a bridge and switch. Originally, there is no bridge device. There is a device called a bridge is not there. Bridge is more like a concept, like bridging between two ports or two NICs or two different NICs. Example, best example, you already know that example. I'm telling that example first. You have a mobile. You have a 4G device, right? 4G signal is there. Now your friend don't have a data balance. He already used a, entire data balance at night only. 1 GB or 1.5 GB he completed. He asks you, please share your internet, your data, please share your internet. How you share your internet? You share your internet?
By using hotspot.
Very good. By using, so you receive a internet using 4G and you are sharing through Wi-Fi part 2, right? So you are some people connected to your laptops using a Wi-Fi hotspots, right? Mobile phone, they are getting a 4G network and you are sharing to your laptops also. So this is a different connection. This is different type. But how it is connected? By bridging. This is the concept of bridging. One concept of bridging. All concepts. One way you can able to understand. In virtualization, bridging is more important. Network bridging is, for example, I have two NICs, two network connections. Now I want to make a connection or a communication between different topologies, like a router. So this is a one kind of network is here. This is another kind of network. You want to connect to both the networks. You can connect it. But you want to make a communication between it. You have to bridge to this one. Then both will be connected. So this concept we can use in different places, including virtualization part. This is my physical machine. This is my virtual machine running inside my physical machine. If you don't get it, this point, guys, do not worry. Okay. So this is also a virtual NIC, and physical machine having a physical NIC, virtual machine having a virtual NIC connection. It's connected to virtual NIC. So what it will do, it bridges to your physical NIC. So whatever the thing is connected in a physical environment, you can able to access. It is bridging between your virtual NIC to physical NIC. Okay, that is also like a VMnet zero kind of stuff, external switches concepts are there. That's why it is very important to learn the basic concepts of networking. Not required CCNA and MCSA guys, but basic concepts of networking is important. Whether you whatever the choose field or a technology you choose. Okay, that's leave it. Next device, two devices are there importantly. The one another one important device is router. All important hub, switch, router. Next is modem. Four devices compulsory. No, guys, router. Router is an intelligent device anyway. Router is also a intelligent. Intelligent means there is a circuit board, not only just a wiring. Hub don't have any specific circuit board, means processing related circuit boards are not there, only just for connecting board or wiring board is there. Okay, so router is an intelligent device, can understand IP addresses, logical addresses like a IP address kind of stuff. Router is a internetworking device. What is internetworking? Communication between two or more
Two devices.
networks.
Networks.
Networks. Network is a connection of two or more device. Networking, communication between two or more devices, interconnected devices. Internetwork is a connection of two or more networks. Internetworking, communication between two or more networks. Internetworking. The router is a internetworking device. It can connect to our more networks. Use of you can use inside LAN communication is there, WAN communication is there. Local area communication, wide area communication. Both places we use. Not like a router, not like a switch. Don't use it for a switch purpose. LAN communication means not we are using for switch purpose, but like a maintaining local communication. LAN, so bigger LAN can WAN for purpose we can use router also, and WAN purpose also we can use it. Yeah, whatever it is, it's a OS layer, layer 3, it is a network layer device. Router is router, the name itself, root. Router, actually it is a router, we call that one as a router, both are same. Both are words, okay? So router is the way like people spell differently like that. That's the point. Okay, no difference. So it's a router. Route means path, right? So router shows best path to reach the destination. You want to reach a particular destination, so that is router. Router uses routing table to know how to reach the destination. Inside of this router, there is a routing tables. Okay, these routing tables will tell how to reach the destination. For example, here in this network, from here to here, I want to go. So in this router, there is a routing table, means it is telling this kind of network, this side, this kind of network, other side. Okay, this router having a routing tables will tell how to reach the destination. These routing tables are created by manually or by automatically. Manually means you enter that routing tables. Manually means it's a static routing. If the routing table is created automatically by using some routing protocols called dynamic. What are these dynamic routing protocols? Are RIP, EIGRP, OSPF, BGP, ISIS. These are the dynamic routing. Okay guys, so what is the router? Router is intelligent device. It understands logical addressing. It works with logical addressing and routing protocol and routed protocol device. It is internetworking device. It connects to our more networks, works in both LAN and WAN communication. Layer 3 device, network layer device. Its root means path. Router means it shows best path to reach the destination. It shows the best path to reach the destination by using routing tables. Okay, so these routing tables are either enter manually or it will be created automatically. So using certain routing protocols. Different routing protocols are there: RIP, EIGRP, OSPF, kind of. That's it for now. Okay. Uh, what is the next point is it's a modem. What is modem? Modulator, demodulator. Guys, understand router?
Yes,
Yes,
sir.
sir.
Ready. We will go to the modem. So modem is a modulator and demodulator. The name modem is so many places. For example, if you are using a FM radio, so when the FM person, while it is transmitting their voice, it is a very low level frequency. But to send it longer distance and to tune to only certain channel, so what they do it? So they add the signal to a very high frequency and they call it as a FM radio, frequency modulation. Then in your radio, so you have to tune to the FM frequency, then we can able to hear that particular one. So like you have a FM radio Michi, 104 fever, 93.5 FM, big FM. Okay, those are all tell what is their frequency, those 93.5, 98.3, these are all frequencies. Once you tune it, so then you can able to get connected and we will able to extract the original signal from it. Normally in our LAN network, the signals are digital signals, but these are cannot be traveled for a very long distances. As I said, our UTP cable is support up to 100 meters only. You cannot transmit the data over the 100 meters, right? So you have to send the signals over the telephone cables. You have to send your data over the telephone cables or fiber optical cables to reach your ISP to other side, right? So how to do it? So your modem connects to your ISP, okay? Modem converts, it modulates and demodulates between your digital signal to analog signal kind of stuff. Signal it is not a single kind of stuff. It I written wrongly, I think so. So check it signal spelling. The modem connects to your ISP, and in modem you already gave your connecting username and password already in modem. So we will give already username and password. So modem will send your details to your ISP, verify your details. Once it is verified, it establishes the connection between modem to ISP. So then you are getting internet. That's why modem connects to internet. So we can say like a modem connected to, so modem makes you connected to your ISP. So your modem is connected to your ISP via telephone cable or what are the cable you're using. We make a connection. We have a connection. And in modem, you have your own username, password kind of stuff inside. So whenever modem is turned on, it sends this username and password to ISP to verify your user identity. Once it is verified, ISP start giving internet service to your modem. Start giving internet service to your modem. So it means your modem is connected to internet. Okay, modem is connected to internet. Okay, that is the first important. Next, once modem receive internet, that internet is we can give it to a device. A device can connect it to a device. But in our LAN network, we have a multiple devices, laptops, desktop, mobile phones, different devices are there. So what we are doing, we want a router to route between your modem connecting to your local private network. So your modem is connected to internet means it's a public network, but your device is in your local network. So obviously we need a connectivity between this local network to your internet public network. That's why you are using router internetworking device. Internally local private network, one kind of network, public different kind of network. So it connects to our more networks, router. Then router is share the network. Okay, it's make it connected to switch. Switch is connected to devices through wires. So these devices will get a connectivity through router. Okay, if you have a wireless devices, you can use wireless access point. Okay, if in case you have a wireless devices in your network like a mobile phone, laptops, you can use wireless access point to connect a wireless devices. This is the very old diagram, guys. This is spreaded diagram. Means there is a modem, there is a router, there is a switch, there is a wireless access point. Okay, so all are communicate. The local communication is connected to the default gateway, that is router. Router to modem, modem to ISP. If you want to put a firewall, firewall is in between router and modem. Okay, so this is spreaded diagram, but thing is Nowadays, all these things are comes in a one single Wi-Fi router. Take some Wi-Fi router, any Wi-Fi router you can take it. Different set of Wi-Fi router means based on the connectivity. Now the routers also coming to get connected. Why it is not opening? Yeah. Some Wi-Fi, some routers are connected like this. It is, this blue color represent WAN connectivity. Yellow color we can connect it to a normal desktop with a wire connection. You have a wireless devices. Anyway, it is a Wi-Fi, so you can directly connect the Wi-Fi devices through Wi-Fi connectivity. So wired we can connect with this yellow connection from ISP to your home. The WAN connectivity goes to this blue WAN connection. Some are built in like a direct fiber optical connections are coming like a Geo type connection. So directly fiber optical connection coming to this Wi-Fi routers. Last time one guy sent pictures to me how he is connected. That is also good. So this is a telephone type connection. So here it is telephone connection. So yes, internet is coming through telephone connection and it is shared through wireless Wi-Fi and as well as the wired connections. I didn't remember who the person is sending. There's so many pictures to me. Such is different. The black screen error again. Forget about it. Mostly like after this one or before this one. So I didn't. But one person is send they're connecting. So then he is asking like, sir, how it is get connected? Maybe it's in a group or a personal message. We don't. Yeah, like this, he said. So one is received and another is connected to another Wi-Fi distribution. Okay, so this is how modem works, guys. Earlier days, we have a separate modem to get connected. Nowadays, we are all combined with the Wi-Fi routers, different type of Wi-Fi routers. So it has a built-in modem and also work like a router and DHCP server, default gateway, DNS server, and we can connect wired connection if in case you have only one or two computers, wired devices. You have more wired devices, then we need a separate switch for that one. Otherwise, not required. No need to buy wireless access point because you're using a Wi-Fi router means there is a Wi-Fi connectivity. So guys, this type of wireless communication also called as a WLAN. What is WLAN? Wireless LAN. WLAN, wireless LAN. Connecting devices wirelessly using Wi-Fi router or a wireless access point. What is WLAN? Wireless LAN. Connecting the devices, wireless devices using Wi-Fi router or a wireless access point. Okay. The next one, that's it. Yeah, some points I've written here. So nowadays, some Wi-Fi routers built-in modems or separate modems required to connect it. Sometimes it is required. So look at some people like even we have this type of connection. The U broadband connection, a fiber optical cable is there. So the fiber optical cable is connected to a modem. The kind of modem it is. Fiber optical cable is connected. Now modem receive internet. It's making a connection, and only one, or maybe two, or three or four LAN ports are there. LAN ports are there. So it's very difficult, like what, how much I need, like either I can able to connect one or two computers kind of stuff. So one way is there, one is like you have a wide connections, then you can connect it to a switch, through switch, you can able to distribute it. Or in our office, we use a Wi-Fi router, separate Wi-Fi router. We have a connectivity from there to here, to your Wi-Fi WAN port. WAN port. And there is a LAN port is also there. And it is connected the switch. This is a Wi-Fi router. This is connected to a switch. This is your switch, 24 pin switch. This is the modem. This part is modem. This is my router, Wi-Fi router. So we receive a internet, main internet from this optical fiber cable to the modem. So modem maintain connectivity. So modem connects the internet. From modem to our router, it is giving. Now router received the internet. It routes to our local network and also to distribute the IP address. So like it is routing it to the switches. And I have a multiple computers, like a 30, 40 computers are there. So one switch is not enough. So I need to connect more devices, more switches are required. So then what I have to, I will connect it like I connect. So it is distributed to a switch, switch to another switch, another switch. Finally, all devices are getting connected. This is separate. In some places, only one. Currently, in my home, we have a Airtel internet. One fiber optical cable came to the check box, router box. Router is giving internet. I need to connect a wire, so I'll go there and connect with the wire. Okay. So this is about your devices, guys. Again, hub, switches, routers, and modems. Hub and switches for LAN communication. Hub is suitable for small network. Switch is suitable for a small and large network. Okay. Hub is a layer 1 device. It's a physical layer device, purely physical layer device. Okay. It does not understand any MAC address or IP address. Hub also can use as a repeater in certain networks. Switch is an intelligent device. It understands MAC address. It learns the MAC address of PCs connected and maps to the switch ports and create a MAC address. It maintains a MAC address. A number of devices, large number of devices we can connect it. It is used for both small and large networks. It's a layer 2 LAN communication. There is a switch called L3 switches or a multi-layer switches can do the both switch function and as well as a function. MAC address table is to help you to send and receive the packets in the unicast way. Next one is the router. Router is a internetworking device. Router is a internetworking device. Understand logical addressing, like it understand IP address and works based on the routing protocols to show the best path to reach the destination. LAN and MAN, LAN communication and WAN communication also we can use the router and it is a layer 3 device. So router shows the best path to reach the destination and using the router uses routing table to reach the destination and the different routing protocols we use the router to build the routing table. So example RIP, ASGRP, OSPF, BGP and IS. The next one is modem, modulator and demodulator. It modulates the signal and send and receive the signal and demodulate and receive. like a internal signals are digital based signals, very low strength signals. So modem will change it to analog and forward to ISP. It is simply say modem connected to ISP, modem connects to internet through ISP. So modem, okay, connecting to IS modem is connected to ISP. So so it will send a request for an internet. So ISP will give you internet. So then modem receive the internet from ISP. Okay. So and modem is use modem is through router. It can distribute the internet access to the devices. Okay, nowadays we are using Wi-Fi routers or routers or which is having built-in modems in the home network. This is a home network. That's why it is small office, small home network. Okay, so your router act like a default gateway. Okay, and when you want to communicate outside of your network, you communicate through your router only. Communicating through your router only. That's why router act like a default gateway. Okay, so these are the main important devices. Of course, there is a devices already explained about wireless access point. What is wireless access point? If you want to connect a wireless devices, you can connect via wireless access point. Like you connected devices through LAN using wired. You connected a wired devices through switch, that is, and you create a LAN network, right? You connected devices to a switch using wire and you create a LAN network. And you have a wireless devices, you can connect through wireless access point and you create a LAN network, that is a WLAN network. That is a Wi-Fi router function actually both as a router internetworking device, means connecting two or more networks, and also connecting wireless devices. Connecting wireless devices. But what is our type of in a home? We are using the routers or Wi-Fi routers contains built-in modem which connects directly to ISP and also works like a Wi-Fi router and a router, DHCP server and DNS also. So these things I explained just now. Modem, you know. So what is firewall, proxy and VPN? Find out these three things. What is firewall, what is proxy and VPN. Want to know about firewall is very simple, guys. When you establish the connectivity with internet, it is a internet is public. So if you want a security to communicate from inside to outside or outside to inside communication, so we can use a firewall. So firewall is based on a list of access kind of stuff. It allow access, deny access based on your configuration. Just like that we can able to proxy and VPN. So we can find what is firewall, use of firewall, what is proxy, what is VPN. Already I told now, so you can try this one. If you find from here, good. If you find from others. Guys, take a small break and we'll discuss about physical topologies. After physical topologies, anything left or IP addresses and OSA layers are there. Okay. So first of all, we'll complete the physical topologies. Then we'll see what are the in between anything we miss. That is what I'm trying to say. We didn't miss it. Okay. Guys, understand, right? Devices.